Hello, a very warm welcome to A-Level Computer Science. I'm the lead teacher for the department. If you have any questions regarding the presentation today, please do email me at karenjones@scarboroughutc.co.uk. Alternatively, if you have any questions about our curriculum in general, please email inquiries@scarboroughutc.co.uk and we'll be happy to answer those questions for you. So let's get started. Okay, so this is our learning journey pathway, and as you can see at Key Stage 5 we have two computer pathways that you can go down. One is A-Level Computer Science and the other one is IT and Cyber Technical Qualification. So if we just discuss computer science first, many students feel that they can't do A-Level Computer Science because they haven't done it at GCSE. This is a myth, it's a misconception, and you can totally complete A-Level Computer Science without having to do it at GCSE, so that is absolutely okay. And this is because the total specification for A-Level actually incorporates everything that you learn in GCSE anyway. So it starts from scratch, you learn absolutely everything, such as like from the CPU to networking to programming. So you can start from absolutely scratch. And yeah, so I wouldn't let that put you off if you are thinking about doing that. So, at Computer Science A-Level, however, there are several units. Okay, so in terms of like what the difference is between GCSE and A-Level, I will be going through that shortly through a few topics. However, just briefly, one of them is the programming project. Okay, so at GCSE, if you've taken it at GCSE, you will know that you'll have completed a programming project. And the programming project at GCSE, the OCR exam board, or well, it's OCR that we deliver here, they give you the tasks to choose from. However, and you only have 20 hours to do it. However, the NEA programming project for A-Level, you define your own problem and then you go away and you solve that problem, okay? And you can choose to do a web development project, you can choose like a database project, anything, or you could do a game, okay? So I've had many projects over the years, they've been all very successful, and the students have chosen their preferred programming language to complete that in. So, and at the start of year 12, you can, and if you've done GCSE computer science and you still wanted to stick to Python programming language, that's absolutely fine, you can do that. I mean, because, you know, Python is still, you know, obviously it's a beginner's language, but it's very useful within industry. Industry do use it. I mean, GCHQ use it, and it's used a lot in data science. So a really, really useful programming language, and it's because it's easy to learn. So you can use that, and obviously, you know, look at more complex topics within that if you wanted to carry on with that. But we also, you know, you can choose a completely different programming language for you to focus on. So that is not an issue. And I know that some of my year 11s going into year 12 have been learning C#. All right, that's absolutely fine. So, so obviously this is going to be one of the components for the whole assessment. This is weighted at 20%. And then at the end of year 13, you'll sit 2 exams weighted at 40% each. Okay. And obviously these two will incorporate, well, this is basically incorporating year 1, the Year 12 content, and exam 2 is incorporating and relating to the Year 13 content. All right. Now, if you wanted to choose, go down the cyber pathway route, you'll do 3 exams, the 3 component in the first year. You'll focus on those. One of them being obviously cybersecurity. There's a whole topic on that. Although we do touch all of these actually, all of these topics are embedded in the computer science specification. But this is more assessment based in Year 13. So it's a little bit like how engineering is. If you know our engineering qualifications at the UTC, it's how they work. So you'll sit 3 exams and you will do 2 internally assessed units, okay, in Year 13, which will be supported by our employer partner, GCHQ. And then on that note, when you do get into Year 12, you will have the opportunity to apply for our Careers Development Programme. And basically, this is a programme that our one of our employer partners will support you throughout your time here with us for the 2 years. And they will engage in various activities throughout the 2 years at several points. And you will improve your skills and knowledge within this area of computing. So also on top of that, you will also get the opportunity to do work experience, okay, and some of the platforms that GCHQ offer, such as their summer schools, such as the Cyber First Advanced Scheme, and they talk about careers and the Cyber First Apprenticeship Scheme and everything. And that is just the QR code to go to their website there if you want any further information about careers for GCHQ. Okay, so we're going to move on now to the frequently asked questions. So the first question I get asked a lot is, what is the difference between GCSE and A-level? What programming language should I learn and how should I study independently? So what are the differences then between GCSE and A-level? So I've just pulled out a few topics that are significantly a step up from GCSE to A-level. One of them being data structures. Now at GCSE, you do learn different fundamental data structures such as arrays and lists, okay, to solve problems, and obviously these come up a lot in programming. However, at A-level, you will need to learn a lot more, okay? So not only will you need to learn arrays up to 3 dimensions, plus records and lists, you'll need to learn other data structures, okay? And these are what I call the higher order data structures. So these are structures to store data, obviously, data structures, linked lists, graphs, stacks, queues, trees, binary trees, and hash tables. And not only are you expected to know how these work, you'll need to know how to create them, how to traverse them. That means how the algorithms work through all of these data structures, and how to add data to and remove data from the data structures mentioned above, okay, and how they're applied in the real world, all right, and what they're used for. So a lot to consider there, and it's a significant step up, as I've already mentioned. Another one leading on from that, which is correlates to algorithms. So at GCSE, you learned obviously computational thinking, which was all about abstraction, decomposition, and then you learned about search algorithms and sorting algorithms and how to produce them, all right? So you need to know these also, including all of this here. So you need to also know, obviously, the algorithms for main data structures, okay, because you can use the some of the data structures together with these algorithms, all right? So you can mix and match. And obviously computational methods is in more depth, and you need to know that for your programming project. And you need to know the suitability of different algorithms for a given task and data set, all right? And I think the biggest step up here is obviously knowing how all these algorithms work, plus these here at the end, the quicksort, Dijkstra, shortest path and A star, and also to be able to discuss and compare them, all right? And what I mean by that is comparing them using the Big O notation and deciding which algorithm that you are comparing, which one is going to perform better on the given task and data set that you've been given, all right? And this is what is known as the Big O notation. It's just a measurement of the performance of these algorithms, all right? So you'll be given a scenario in your exam and you'll have to explain this in the Big O notation terminology, okay? And that's all about performance and efficiency. Okay, so the final one is the difference between GCSE and A-level programming techniques. And in GCSE, you started off in Year 10 learning about all of these programming techniques on the left. So you need to obviously know these at A-level and plus these on the right, okay? So at A-level, you need to know what recursion is, all right? And you also need to know how that's compared to an iterative approach, and which way is better, and you need to be able to explain the differences of those. You need to also understand what the differences between global and local variables, modularity, parameter passing by value and reference. And this one here is really important. I mean, everything's important, but this one here you'll need practice with. So this one is all about object-orientated techniques. Well, it's the object-orientated paradigm, and that is a style of programming that you need to evidence in your programming project, okay? And if you wanted to stick to Python, because you're comfortable with that from GCSE, that's absolutely fine. I had a student who completed his programming project in Python, and he was looking at it in more detail because he used all these object-orientated programming techniques, and by that it's just more modular, okay, and it's based on objects. That's all it means. And I know that some students in Year 11 have been learning how to program in C#, and you've probably are doing this already without you realising that you're using all these techniques, or key terms is what I call them. And the key terms that you need to learn for this are inheritance, encapsulation and polymorphism, okay? And like I say, if you've already been programming in C#, that you probably are already familiar with this, all right? But you just need to learn the terminology that underpins that, the practical elements. So so a big step up, but this you'll need definitely practice with. Okay, next question. So what programming languages should I learn? Now, I always get this asked a lot, and some people say, oh, I should learn the most popular language, but not necessarily. You learn the language that you want to learn, okay, and that all depends what sort of pathway you're going down towards. And not necessarily, some people don't like programming. Computer science is very broad. You don't have to go into programming. You can become a data analyst, okay? You could become a designer for a website, anything, okay? So I've just got this image, okay? Now, if you've never heard of Stack Overflow, that is just a website that you can go to where sort of like professional developers go to, programmers and alike, go to to ask questions about problems that they've got with their code, right? Because don't forget, and this is what people forget when they're starting out learning how to program. They get very frustrated because they come across errors and they think they can't do it and then they give up. Well, that's just the nature of programming. 90% or so of software developers' time is taken up on solving how to fix something, right, that they've come across in their programs. And this is what Stack Overflow is. So it's a website where it's a platform where software developers, professional software developers can go to ask questions to see if somebody else can fix their problem for them, all right? Now, on this site, this is where I've got this bar chart from. And this is the most popular programming languages at the moment of 2020, all right? So at the top, we have JavaScript. And JavaScript is a programming language used in web development. And it controls the behaviour of web pages and certain events and animations on a web page, okay? Now, we also have HTML, which obviously, well, it's not obvious if you don't know what it is, but HTML is the language to create web pages, to display them on your screen. And then the CSS, which it stands for Cascading Style Sheets, that is for using to design and all the design aspects for your HTML page. Okay, so you can access all the HTML elements and you can design them using CSS. All right, that stands for Cascading Style Sheets. We've also got SQL, which stands for Structured Query Language, and that basically you can use that to create databases, to query databases. You can edit databases, delete them, and all sorts. Okay, so all of these four you will need to know for the entire specification, okay, for computer science. These are included in the specification and you need to know them anyway, okay? So you'll be doing a topic called web development later on in the course. And then, of course, the fourth popular one is Python. And, Python is really big in industry. It's used a lot in data science. Java, obviously that's used for Android applications. And then we've got these two down here, which is Bash, Shell, PowerShell and so forth, and C#, which is another popular one. And if you are thinking of going to university, this is the one they use for students to learn when they first start in the first year of uni. Right, so on top of that, I would suggest that you learn what assembly language is, and you've touched on this, some of you, at GCSE. When we first started way back in year 10, you needed to know basically what assembly language is, okay? And you can do this by going over to the Little Man Computer Simulator. You just type that in into your browser and this will come up, and it has built-in programs, okay, that you can run, and then it will show you how they're run in the CPU and how they're executed in the CPU, okay? So assembly language is a low-level language. All these here are higher level languages, okay? They're closer to the English language and the more sort of intuitive. This is not so intuitive. Some of the instruction set are not so intuitive, okay? So I thoroughly recommend that you go over and learn what assembly language is and have practice with that, because that will definitely come up in your exam. So along with that then, that there's a few more languages that you can use. Obviously I've already mentioned Python, any of the C family, so we've got the C# down here, but you can also use C++. Java, Visual Basic's a good one. If you wanted to move on from Python, you can go to Visual Basic, because that's similar to C# and Java. We've got PHP as well, so PHP is like a web-based one. And I did have a student complete his all in PHP actually a couple of years ago, and he created an application for a maths type based learning platform, a little bit like Hecate Maths. Okay, so really good. You got A star for that. Delphi, I've never had anybody learning Delphi as yet. And Lua, which is a new one for me this year, and this one is a programming language to create 2D games, okay, using the Defold platform. So a lot to consider there. So, but if you wanted to stick to Python, that is absolutely fine. Okay then, so independent study is what I wanted to go over with you now. And I do wanted to sort of emphasise on this because a lot of students do sort of like find this hard to begin with at the start of year 12. And it is a real step up from GCSE to A-level. Okay, because obviously at GCSE you're used to your teachers guiding you and telling you when your work needs to be handed in, but it's a little bit different at A-level, well, a lot different at A-level, and we won't be chasing you for work, okay? So you will have a lot of independence and you will need to be able to study independently. And one of the methods for this is what I call, I sort of direct students to use, is this Cornell note-taking. So prior to lessons, I will ask students to arrive at the lesson with some body of knowledge in preparation for that lesson, and I would then direct you to go away prior to the lesson and say, right, we're going to be doing this week, we're going to be learning about DNS, we're going to be learning about networks, and then prior to the lesson you'll need to come to the lesson with that body of knowledge, so we've got more time in lesson to go over misconceptions, right? This is called the flipped learning approach, and the Cornell notes taking is a really good way of retrieving that knowledge over and over again. And this is when you become a mastery and be able to talk about that topic in depth and detail to somebody else, okay, when you've learnt something. So the whole idea of this is that you take notes, and then after the lesson or after the lecture or after your research, you will then look at your notes and think about, oh, what questions could I ask about that? And then you would then revisit this and then try and answer these questions in full, and then you would revisit it again, okay? So over the course of, like, say, 4 weeks, you'll have had several opportunities to retrieve that knowledge, and then you become a mastery at doing that, okay? So independent study is a really, really important aspect of any of your A-level studies here at Scarborough UTC. So, without further ado, I'm going to be giving you some tasks to do, and what I thought that would be really good is for you to do some web development. So, and I thought, oh, it'd be really nice for you to create an e-portfolio of yourself, okay? And you can use this e-portfolio throughout your time here at Scarborough UTC, and I have just made a demo here. So we've got this really cool slider here that you can scroll through using these toggle buttons. We've got the scrolling words as well. And then when we scroll down, we've got our nav bar, which is this bit here. And then when we reach so far, look at the nav bar, if you look, it's sticky. All right, that means it will stay at the top there when we go down the rest of the website. So, and then we've got the about page. So these work as well. So we've got about, we've got skills, we've got stats, and then contact. Okay, and then we could have had another one for portfolio. All right, now you can design yours any way you want, but I thought that it'd be really good if we could create one of these, and then everything you create then you could put on this website. Okay, you can store it in here, and then showcase that, and that would be a really good opportunity for you to showcase your work to employers, okay, or to university if that's what you wanted to do. All right, so I shall see you in the next video.